Okay, so today's lesson we're going to be looking at compound interest. So in the previous lesson, we looked at simple interest. And just remember the difference between the two is simple interest is when interest is only paid on the original amount, which is also referred to as the principal, whereas compound interest is where interest is paid on the original amount plus any interest that is added on throughout the life of the investment or the loan. Okay, so compound interest, you pay interest on interest as well as the original amount, whereas simple interest, you only pay interest on the original amount. Okay, so how do we calculate compound interest? We have a formula right here. And in this formula, we have A equals P times 1 plus I to the power of N. So what do each of the variables stand for? A is the final amount. Okay, after however long the investment or the loan is, what's the final amount? That would be the A. P is the principal. So that principal, remember, is always the original amount invested or borrowed. I is the interest rate, and notice here for compound interest, it's the interest rate per compounding period. And we'll talk about what that means in more detail just a little bit further down on the lesson. And the N, the exponent there, is the total number of compounding periods that have occurred. And again, we'll talk about that, well, actually right now here in this table. Okay, so in many cases, interest is compounded more frequently than once a year, right? So in the simple interest formula, interest was basically compounded or applied, we can say, once every year. So all we had to do was take whatever the percentage was in the question and change that to a decimal, and we were good to go. Here in compound interest, sometimes the interest is applied. Again, the word we use here is compounded more often than once a year. Okay, so what would that look like in a question in terms of how do we figure out how many times interest is compounded in a year? Well, we have to look for one of these words in this first column here where it says compounding period. So the question will always tell you what the compounding period is, and based on whichever one of these words is used, then we know what number or how many times the interest is compounded per year. So if it says annually, that means once a year, right? Every year, one time a year. If it says semi-annually, it means 2 times a year or every 6 months. If it says quarterly, that means 4 times a year or every 3 months. If it says semi-monthly, that means twice a month. And if it's twice a month, it is 24 times a year, right? 12 months in a year times twice a month gets us 24. Bi-weekly means every other week. So basically, we have 52 weeks in a year. If we're paying every other week, 52 divided by 2 is 26 times a year. If it's weekly, it's once a week. And because there's 52 weeks in a year, that means your interest is compounded 52 times in a year. And if you ever see the word daily, that means every day. And we'll assume it's not a leap year. So that means it's compounded 365 times in a year. Okay, so we are more concerned with this last column because this is the number that you're going to be using in the formula. Okay, so please familiarize yourself with what each of these words refers to in terms of how many times interest is compounded in a year. Okay, so looking at example 1, if we are calculating N, and remember if we scroll up here, what is N? Total number of compounding periods that have occurred. Okay, so this table tells us how many compounding periods in a year, and then we have to multiply that by however many years the investment is. Okay, so looking at example 1, if interest on an investment compounds quarterly for 5 years, how many times will the interest compound, right? So in other words, what's the value of N? Well, how many times does the interest compound in a year? Well, we know it's quarterly, and if we look up at our table here, quarterly means 4 times a year. Okay, so that's where this 4 is coming from. And how many years is the investment? 5 years. So 4 times a year times 5 years means it'll compound 20 times. So our N value in this case would be 20. So if we're plugging this into our formula, if I move up here, this N value, the exponent, in that question would be 20. Okay. The other thing we have to calculate in this formula before we plug it in is that I value. So the I is interest rate per compounding period. So let's look at an example for calculating I. Okay, sorry, and before we calculate I, let's see how would we do that in terms of what is the mathematical operation. So to use the compound interest formula, we need the interest rate within one compounding period. So to find that value, divide the yearly interest rate by the number of compounding periods per year. Okay, so if your interest rate is 12% and there's 12 compounding periods in a year, you would do 12% divided by the 12 compounding periods, which would give you 1% or 0.01. Okay, so whatever, the question will always give you the yearly interest rate. You need to take that yearly interest rate and divide it by the number of compounding periods in a year. Okay, so let's look at the example below here. To calculate I, the yearly interest rate, like I said, this will be given to you, is 2%. Okay, and interest is compounded bi-weekly. So we need to figure out, what does bi-weekly mean? Well, bi-weekly means every other week, so 52 weeks in a year. If it's every other week, 52 divided by 2 tells me that interest is compounded 26 times a year. So we take the interest rate of 2%, convert that to a decimal, 0.02, and divide it by the number of compounding periods in a year, which is 26, which we got from this bi-weekly. Okay, so again, this is information you will always be given in the question. You'll be given the interest rate, and you'll be given the compounding period. Okay, so you'll have to basically look at whatever the compounding period is and translate that into the number of times per year. Okay, so bi-weekly translates to 26 times a year. That's where that denominator comes from. So our I value then is 0.02 divided by 26, which gives us 0.000769. So in the formula then, this here, what's in the box, that's what we would plug in for the I value. Okay, so let's look at an example here where it's asking us to use basically the formula for compound interest. So it says here finding the final amount, so the future value, so we know we're solving for A, right? So calculate the amount of an investment after 3 years if $500 is invested at 3% compounded quarterly. Okay, so all the information we need is in the question. Okay, so remember our formula, which is right here, A equals P times 1 plus I to the N. So we're solving for A. We need to figure out what P, I, and N are. So P is easy, right? It's whatever the original amount is. So in this case, the original amount of the investment is $500. So your P value is 500. The ones we have to do a little bit of work for are I and N. Okay, so remember, N is the number of compounding periods during the term of the investment. So what do we need to do? We have to take however many times it's compounded in a year and multiply it by the number of years of the investment. So this tells us compounded quarterly. So that means 4 times a year. That's where this 4 comes from. How many years is the investment for? Well, we're told right here, 3 years. That's where that 3 comes from. So 4 times 3 tells us our N value is 12. And the last thing we need to calculate before we start plugging numbers into our formula down here is the I value. So just like we did above up here, take the interest rate, convert it to a decimal. So 3% converts to 0.03 and divide it by the number of compounding periods per year. Again, that number is 4 because it's compounded quarterly. That means 4 times a year, and that's where that 4 comes from. Okay, so our I value then is 0.03 divided by 4, which is 0.0075. Now we have all the numbers that we need. So the next step is to simply plug in your P value, your I value, and your N value, and then basically let your calculator do the rest of the work. And you can see here, once you solve, you get a final value of, or a final amount of 546.90 cents. So what this tells us is if you invested $500 at 3% interest compounded quarterly for 3 years, that $500 would be worth $546.90 after 3 years. Okay, so you'd make basically $46.90 on your investment after 3 years. Okay. Last example here, the other way you could be asked a question, technically you could be asked, I guess, to solve for AP A or P or I or N, but we're going to stick to basically solving for either A, which like we did in example 3, or example 4 could be saying to solve for P, which says here finding the principal or the present value. So in this case, you know the final amount, you want to solve for the principal amount or the present value. So looking at our question here, example 4, Sarah takes a loan from the bank at 4.2% compounded monthly. After 5 years, she owes $59,024.61. How much did she borrow? So we'd have to read this question basically and figure out that we are given the final amount that she owes, and we are asked to figure out how much the principal was, because it's asking us how much did she borrow. So basically we want to know at the start of this investment how much did she borrow, so that means we're trying to solve for P, which is the principal. We know the final amount is given to us in the question, $59,024.61. And as always with these questions, we've got to do a little bit of work to solve for N and I. So N, we take let me look at the question here again. How long is the investment for? 5 years. So there's your 5. How many times is interest compounded in a year? Well, it says compounded monthly. So monthly means 12 times a year. So your N value is 12 times 5, which equals 60. And then I, as always, we take the percentage of the interest, right, 4.2, and convert that to a decimal. So 4.2 divided by 100 is 0.042, which is the numerator here, and divide it by, again, the compounding periods in a year. So if it's compounded monthly, as we figured out for N here, it's 12. Compounded monthly means 12 times a year. So our I value then is 0.0035. So what you can do then is you could plug all your numbers into the formula as it is right here, but just note that the P is not isolated. So you could plug your numbers in and then isolate P, or you can do what we've done here, is isolate for P first. And how do we isolate for P? Well, right now it's P times 1 plus I to the N. So to isolate for P, so we're doing P multiplied by 1 plus I to the N. The opposite of multiplying would be to divide. So we divide both sides by 1 plus I to the power of N. So P is equal to A over 1 plus I to the N. And at this stage, again, plug in your numbers, let your calculator do the work. Okay, so there's your A value, there is your I value, 0.0035, your N value is 60, and you go ahead and simplify that, and you'll get a P value of 47,861.96. So what is that telling us? So just as important as it is to figure that out or put your numbers all in the right spot, we should also know what that actually means. So what this number means is, this is the amount of money that she borrowed at the start of the loan, or whenever she took the loan. She borrowed $47,861.96. So based on borrowing that amount, and this interest rate and this compounding period, after 5 years, she ended up owing $59,024.61. Okay, so remember A, if you're solving for A, you're just looking for the final amount. If the question asks you for the final amount the investment is worth, or how much the person owes after a certain amount of time, then it's A. If you're being asked for the current amount, so how much did she borrow right now, like in this question, or it could say your investment is worth, X amount after 5 years, how much did you invest now for it to be worth that much? So anytime you're asked for the present value of something, you're solving for P. And if you're asked for the final amount, you're solving for A, like we did in example 3. Okay, and as always, you have your practice sheets there. So if you go to the blank file that I've posted for this lesson, you'll see the practice sheet there, obviously without the answers. And then your full solutions are in the file that says completed note, or the filled in note. Okay, so there is the second lesson of our final unit on compound interest. Okay.